Alright, well, hello AP Physics students, and welcome to this video lecture that's going to introduce our new unit, which is going to be all about momentum. A little unorthodox that we're introducing this before our unit test, but due to the weather, we do what we got to do. So this is just going to be a quick video lecture going through what momentum is and also what impulse is. The two are directly related to one another, and then later on in this unit we're going to look at conservation of momentum, and even conservation of momentum and conservation of energy together. So to start out, momentum is kind of a weird quantity that all moving objects have. And the best way that I can describe it to you is that momentum is what we call inertia in motion. Okay, so let's say I had a, I don't know, I'm going to draw one of my really bad cars here. Okay. All right, we got a little car, and then we have a big semi-truck. I don't know why the cab of the semi-truck looks like that. Don't question it. But let's say that both of these vehicles were moving at a velocity equal to 30 meters per second. Okay, well, I think it's pretty clear here to say, oh, well, the truck has more momentum because the truck has more mass, so it has more inertia. It's going to be more difficult to get the truck to stop, and that's the whole point of momentum. It's inertia in motion. Any moving object has momentum, but what we really are going to start looking at is, conceptually, which has more momentum, and it's the one with more mass, more inertia. Which one's more difficult to stop? Okay, our mathematical definition for momentum. Okay, we use this goofy symbol. It's a fancy looking P. It's called rho. So momentum is based on, if it's inertia in motion, it's based on mass and velocity. So our mathematical definition for momentum is pretty straightforward. And our units for momentum are not very creative. They're just based off of the units of the two variables that we have in our equation. So the units for momentum are kilograms times meters per second. Now, the type of quantity that momentum is, because velocity is a vector quantity, that means that momentum is also a vector quantity. So whereas with energy we didn't care about direction, momentum we have to start caring about direction again. And that's going to be even more important when we get into conservation of momentum scenarios where we look at various collisions. All right, now impulse is simply a fancy word for a change in momentum. So impulse, and I'm just going to write this as a change in momentum, is equal to mass times a change in velocity. So I want us to understand, though, how does this change in velocity actually occur? What do we have to do to actually cause a change in velocity? So this all goes back to Newton's second law, where we say that, whoa, I'm not sure what happened there, where we say that a net force causes acceleration. Okay, well, now what is acceleration? Well, acceleration is a change in velocity in some time interval. So I can rewrite this as, net force is equal to mass times a change in velocity over time. Well, now if I want to simplify this, get that time on the other side of our equation, what I'm going to end up with is I'm going to have force times time is equal to mass times a change in velocity. This is a huge equation for us in this unit. This is what we call the momentum impulse theorem, where we say that a change in momentum is actually caused by a force applied over a certain time interval. Okay, and we can use this equation right here to help us think conceptually in a lot of different scenarios. Impulse becomes super important. Just a real world example, a boxer. Okay, a boxer, to minimize the force that a boxer experiences, well, they're going to want to increase the amount of time of that collision. So how do they do that? Well, they roll away from a punch. They don't go towards the punch. They roll away from it to minimize the amount of force they feel in that collision. So we are going to use this, this equation right here pretty extensively to help us think conceptually through problems, but also to solve quite a few problems as well. So again, impulse being a change in momentum, the units are simply kilograms times meters per second. And again, it's also a vector quantity because, again, it is just a change in momentum. But it should make sense because force is a vector and change in velocity is also a vector. Okay, so very short video lecture, just getting us thinking about momentum and impulse to get us off and running on Thursday with this. Again, exam will be tomorrow on work and energy. All right, take care of you physics students.